Alright, I have this vintage Koolatron p10 electric fridge and food warmer. Originally had a plug that had a cigarette socket on it. They give it the 12 volt. I never had that one. I got this at a resale shop. But it goes along with the idea that I have of using those peltier chips or semiconductor um, for heat and cool. And sometimes they're called thermal generators. These are the things that are used in um, on the fans for that you would put on top of the wood burning stove, for example, like this. So what happens is the base heats up, travels up the aluminum here, and then you see the thermal generator sandwiched in there. We'll have some thermal paste on it, and then you've got the motor. Now I don't know if these motors are 5 volt, 12 volt yet. I don't know how much it puts out, but the idea is that. So in this one capacity, it can actually generate electrical current through heat, but in another capacity, you can give it current, and then one side will be hot, the other side cold. And so, there's applications for CPU cooling that you sandwich up against this a water radiator, and it flows through, and then it gets cool down your CPU that way. But in turn, it could also heat it up. And so, we'll go inside of this and do a little bit of research on it. This has a refrigerator and then a max cold setting, but also cold and then heat. And so when I ran the cold, I was getting that it ran at, and I think this has 3 of these generators, but I'll open it up again and do some research. But when I initially ran it on super cold mode, I was getting that it was only taking 3 amps to get. Then you could start feeling it get cold, and it just does. It gets it cold by mounting the cold side up to a metal insert, and then through the induction through the metal, then the whole thing will cool. Probably this is old technology. So, what if you did this to a Yeti or one of the kind of coolers now that really hold um, the temperature in there a lot better. There is a fan here, so I know this fan is an old style fan. I know I could go with a lower, and actually what I plan to do is put in some of the 12 volt fans that are now out on the market with kind of the squirrel cage setup. So only thing I think that this fan is doing is not like blowing cold air into the this compartment here. It's actually cooling off like the heat part of the generator. So you can get these. I mean, today I bought 5 of these for like $16 at 12 volt at 60 watt. And so I didn't turn the hot on, so I will do that to see how much amperage the hot side. My theory is that it's going to be the same. And then we'll kind of see, look at the circuit board and see how they kind of wired it and that sort of thing. My theory again is that the heat is going to also run the 3 amp, which is going to be a great opportunity to to get some heat and cold in some different situations and open up kind of different ideas for bringing in heat and cold minus, other than using the energy draining way that we do it now with heating up an element or filament or whatever. So I'll be a little bit hooking that up, see how much amp draw for the hot side. I didn't want to just go like from cold to hot. Probably wasn't going to be a real good thing to do. So we'll check on that later. And so just taking a look at it, I mean, I've looked at it, but I really haven't really looked at it. So you see here, probably got, you know, definitely we could go with a newer style fan. We've got the heat sinks here, pretty decent size. Now my wonder is how many of these little peltier generators do we have? Again, this is maybe, I don't know, circa 1970s, maybe early 80s. So what did they have to work with back then? Let's see here. That whole thing might, so it looks like they have a whole big one maybe. Looks like we've got our red wire here and our black wire there. So, could you even, now let's, I want to take that off just to see what they actually have there. And again, our two wires that go. Now there's all these other wires here. See, this is a early style board with bigger connectors, unlike the boards today. Might have even been made in America. Got a capacitor there, we got a fuse. That's where I cut that so I could add in the power supply. Alright, I think I'll go ahead and take these screws off here just so I can get a look at what this wiring's doing here. So what we have here, it's really stuck. So I really don't know if I want to take it off, but I really kind of do, because I want to see how they've wired this and what the different wires are for. I guess would be different. One would be a reverse polarity, one would be to get the heat versus the cold. We've got two layers of some sort of probably the old sticky double-sided type tape here. Alright, I am about to get it off here. Seems like I might have to figure out how to get it stuck back on there again. This is a pretty interesting little heatsink contraption they got going. Oh, wow. Interesting. A little peek in there. Block of aluminum. Oh, look at that. They just got one. Okay. Oh. Okay. Looks like we've got, wow, that is an old, look at that. You can actually see the, how that, you know, if you'll do research on these semiconductors, it's, you know, like a negative, positive, and then that's what creates whatever it does. And then we got our wires that go into, this block here. I would assume that might be, so we have a green and a yellow going there, and then we have this other same kind of I have to look that up to see what they call that. An S95 250 volt 5 amp. There's one there, and then there's one right there. I'm assuming it will be somewhat similar. And then we've got a green. Looks like we've got two of the green wires coming in right there together, and then two of the yellows together. I wouldn't be surprised if that wasn't a thermostat. But thought would be that this big block of aluminum would be okay. So I'm gonna put a good fresh layer of thermal paste. Oh, it hasn't come in yet, so I'll have to wait. Okay. And then so our black, it looks like, what is that, a brown? I need to buy some double-sided tape too. Well, it looks like this tape was glued on there. Okay, so again, I want to do some work to that. I want to put a better fan on it. It's kind of like a weird, I don't even know where the motor is on it. Let me check that out. I think what that looks like. Okay, it's kind of a big motor. In an old style, would be a big hog of a motor. Could definitely get a better motor in there. That will probably move more air and use less amperage. We'll get that one a little bit better. Alright, next I want to kind of look at this circuit board and see what we got going on here. Here's the fan. I like how they have that soldered in there like that. Okay, so red. Let's see. It's like a brown. Is it a brown? No. Oh, it's a red. Looks brown and red and black. So these are for the thermal generator, semiconductor, whatever you want to call it. These in theory are going to be somewhat sort of a thermostat or current control. So overall, we've got a lot of like kind of built-in thermal protectors. I'm assuming that that's a thermal protector. That would be a thermal protector, and that would be a thermal protector. Got a fuse. Looks like we've got a resistor. And I would imagine that these resistors are for the different settings that you have when you go from heat. And then this switch right here is the one from just regular refrigeration to max refrigeration. So, and then here in the central part we have I'm assuming the kind of the thermostatic control. Maybe. R5, resistor 5, resistor 6. TR1, TR. I wonder if that's resistor 1, resistor M plus, M minus. M plus, okay, M plus, M minus, that's for the fan. Okay. Maybe that knows more about circuit boards would know. I mean, it's just a simple circuit board situation. Those are diodes, I think. What they've got going on. What I'm wondering is, I don't know if this is a 12 volt. Got 12 volt going through here, or if it's resisted, or if it's hold down, and then how they go from heat to cold. If it's just kind of a reverse polarity kind of a thing. If I look at that switch right here, the switch, no, I don't see. Maybe that. Let's see that switch. Go up. See the red one. It's going to be the main power, and then I think versus up or down is going to. Let's see. Down hooks it in. The fan's always hooked into that. It goes down to the thermostat or the overload protector. I don't know. I'll be playing around with them as I get them and seeing if I can do the hot versus cold, and then whatever kind of thermostatic control that they've got going on there. But I might as well. I think I'm just going to leave it off right now and just kind of play around with it after I get it redone and put the new tape on and put the new treat paste on and stuff like that, and the new fan. Alright, I lied. I'm going to go ahead and try it out anyways. So there's no on-off, so you have to have it in, I guess, whichever situation that you want. I'm going to go ahead and have it switched to hot right now, and just leave it like this. I did mix up on accident these colors. Normally I would have wanted to have blue being hot, but blue is, and I do it all the time, I don't know why. Blue is going to be my ground. Right, and my theory was correct that even on the heat setting it's going to be 3.21 amps. Fan comes on. So, and my theory would be that these are going to get, since it's set on heat now, these are going to get cold, and then let's make sure that the heat light is on. Heat light's not on. Let's see. I don't know. Let's see. Maybe it is on. Okay, I'm gonna check some checking voltages to see what kind of, there's going to be a switching voltage. Adjusting temperatures, 71 degrees. It's starting to get hot there. 86. So definitely is heating up in there. So this would be where that big piece of aluminum attaches. So then right over here we're at 70. I'm going to close the lid and see what it heats up to. And we're still at 3.03, so it's kind of going down. I can bring that down when I change that fan out. I need to take temperatures here. .71 degrees. Water ambient is 70, so not much of a difference here. But this would be right about where, maybe warmer there. Let's see. Alright, still no hot light on. Maybe that hot light only comes on once it gets to a certain temperature. Alright, still no hot light. Let's see, fan's still running. Probably been 2 minutes, 3 minutes, maybe 5 minutes. Definitely hot to the touch right there. Let's see what the ooh, 109. Okay. 76 on this end. 74. I'm interested to see what they've got it thermostated at. So we've actually dropped our amperage. We're at 2.88. Okay, now let me see the temperatures here. Feels like it's still 73, so we are higher than what we were before. Alrighty, okay, now we're going to check some voltages. Alright, let's check some voltages. Ouch. Okay. Yeah, I'll just put it down and alrighty, let's see. Where's we should have 12 volt coming in here. Volt coming in. We've got a minus. That was my theory there. Is that when it goes to heat, it probably switches around on. It's a minus 11.15. Should have 12 volt going here. The fan. Oh, it says 6. I think that's a 6. Oh, so it's not a 6 volt fan. Let's see. I mean, that's not a 12 volt fan. Trying to see which one's the positive. Well, this is saying that the brown is the positive. Wonder if that changes though. Oh, it's saying brown is the negative, white is the positive. So white is the positive. And that should stay the same. So I had bought a 12 volt fan for that. I don't know It might be a 12-volt fan might work for that. But we're only getting 6 volts, so they've got that resistive down. Don't want to switch it over yet. I want it to cool down before. I don't know if that's going to cause problems if you go straight from it while it's hot to where it's cold. I would think that you would want it to cool down first. Let's check some temperatures. So it's gone up a degree there. So after it's off, I've got the power disconnected from here. I guess the generated power from these peltier plates continues to turn the fan. In doing a little bit more research, so I guess the more that these heat sinks draw or allow for a temperature change, then the cooler it will get. It's gotten to about 150 in there. It probably will continue to go up, I guess, until it reaches the temperature. But then with this, providing power input to this fan continues to allow it to blow to cool things down.